Before I start speaking deeply about this presentation, first I would like to introduce the member of my group, starting by me, Anwar Al Fawdaeai, followed by my friends Ahmed Miftah and my friends Abdul Aziz. Second thing, I would like first to thank also my lecturer, Dr. Gnati, who gave us this chance to speak in front of you. Also, I'm thanking all of you in advance for your attendance and listening to me. I would like first to give a simple comparison between what we have studied in our book and what I'm going to present you by today to make my presentation interesting as much as I can. Actually, what we have studied in our book is just using electrical power, current and voltage combined together with the axion pulse for measuring unknown quantities such as resistance, capacitor, inductor. While what I'm going to present you by today is using another energy. We are going to use the sound as energy for measuring also another quantity. This quantity is the distance. So both of them, this book, our book, Electrical Instrumentation Measurement, and my presentation, sharing the same purpose, measurement and instrumentation. Okay, and sound as energy. May also two questions pass through your minds. First, how sound could be used as energy, and what does it mean sensor? Basically, the one which, or the parameter which creates the energy is the frequency. So we can say, if there is no frequency, that means there is no energy. If there is no energy, that means there is no sound. Sound and music. Also the meaning of sensors. We are going to introduce what does it mean, sensors. All the sound that we receive it by our ear, everyone knows has a limit frequency from 20 kilohertz up to 50 kilohertz. So may you ask yourself, which is the region who is responsible to receive this frequency in our ear and send it to our mind? This is called in medical calculator. Calculator exactly as acting as the sensor. So from this point we could understand what does it mean, sensor. Sensor is a device has the ability to receive the frequency, send it to another device, which also has the ability to convert it into another logical quantities to be measured. So from this time we could understand what does it mean, sound, and how sound could be used as energy. At the same time, what does it mean, sensor. Both of them, sound or ultrasound, the frequency which is more higher than 50, ultrasound. Infrasound is the frequency which is more lower than 20 kilohertz. We are considered today about the frequency which is more higher than 50 kilohertz. So ultrasound combined together with the sensor create a very special device called ultrasonic sensor distance. This ultrasonic sensor is a device, generate high frequency sound. So this sound gonna be, or the frequency gonna be hit the object and then return back to the receiver. So we are going to explain deeply this operation. Okay. So now how this special device is working, how ultrasonic displacement or ultrasonic sensor distance is working. First of all, there is a noise generator. Noise generator is a device which creates a high frequency, or sometimes called mechanical vibration. So once the noise generates a very high frequency, it's going to another device called FM modulator. FM modulator is a device that has the ability to modify the frequency, so can be matched with a request penetration. What does it mean that? For example, if we take the radar as a symbol, radar sends the frequency. So once the airplane, for example, is moved on the radar, the frequency is hit on the airplane and return back to the receiver. The receiver going to transfer this frequency into a logical quantity to be measured. Why? For example, if another bird, small bird, is flying above the radar, of course the frequency will not catch or capture the bird. Why? Because this frequency is going to penetrate through the bird. So that's what does it mean, FM. FM has the ability to modify the frequency, so can be hit for some object and cannot be hit for another object. Another device is called amplifier. Amplifier is, from the name you could understand what does it mean, amplifier is to amplify the frequency up to sometimes 20,000 kilohertz, and then transmitter to the air or another medium. After that, we are going to introduce the receiver. Receiver or the receiver circuit. Receiver circuit is acting opposite the transmitter circuit. We are going first to receive the frequency and then reduce the frequency to very low frequency. You see that the reverse base, the reverse base of the amplifier. Forward base and reverse base. So reducing the frequency and then at the same time modulate this frequency into a small signal can be matched with the logical quantity to be measured at the analyzed cross-corral computer. Ultrasonic transmitter circuit. We are not going through this deeply so much because it's a complicated circuit. As we just know here, it's just amplifier circuit to amplify the circuit, and then the transmitter is another amplifier to reduce frequency and then translate it into a logical quantity to be measured. That's all. So all the device that we explained it, this is exactly the prototype circuit. And this is also the receiver circuit. So from the transmitter, the receiver going to receive the circuit, reduce the frequency, and then translate it into a logical quantities to be measured and appear on the screen of the computer. Now we are going to introduce some of the application for the sensor. Some of the most application of the sensor is the ultrasonic wave sensor, which can be used in the parking sensor system. For example, if we have our car, some of the modified car has a sensor at the back. So once the car is nearby the wall, the car is going to produce some sound, so alarm you that you are near from the wall or near from some object. How this is acting exactly as ultrasound displacement sensor is acting. First, the transmitter is going to transmit some frequency. So this frequency has a limit distance. That means if you are too much far from the object, the frequency cannot hit that object and return back. But if you become much near, the frequency has the ability to hit the object and return back to another transmitter. So it's going to introduce the sound for you to alarm you that there is object. Another application here is ultrasonic sound waves. This is also another device giving the distance from the surface of the water until the depth of the sea. So it determines the distance from the face of the sensor to the surface of the water and level it down, of course. So, of course, this is the velocity is going to be changed because we are trying to find the distance in the water. We are not going to try to find the distance in the air, so it's different. The media is different, so the velocity is going to be different. So here also another simple application how this device is working. First, there is oscillator, the one which brings the frequency, and then amplify this frequency, then transmit this frequency using the speaker. After that, hit the object, then return back to the object and return back to the receiver. After that, amplify the circuit. Then, of course, determine the time elapsed and give it into logical quantities to be measured. So, for example, if we found that there is ultrasonic producing a high frequency on the air, so it takes time. For example, I have take time 4 milliseconds from the frequency has been transmit until it comes back. So we are going to divide simply the distance. Distance is the constant air, the medium air constant is for 340.29. Divide by 2 because we are going just to measure one way. So we are going to say 54 multiplied by 4 divide by 2 to get the distance, which is 0.680 meter. As a conclusion, we could say that there are still some of great unknown energies yearning to be discovered by you. As long as we keep in our mind that everything is possible to achieve, except the day past cannot be returned back. Thank you for your attention.